Number 11. What are the solutions to the equation? Okay, what do solutions mean? X-intercept. Okay, so I'm looking for the x-intercepts. Well, in order to do that, I have to graph. Can I graph this equation how it looks? No, what do I need to do? Move that -5. How do I move a -5? Add 5. So this is really going to be -3x squared plus 6x plus 5. So I'm going to go graph that. -3x squared plus 6x plus 5. Go find my x-intercepts by tracing. Sorry. NU5, 1. My first 0 is x equals -0.633. My second 0, or solution, x equals 2.63. Okay, so what I got to do is I got to turn my answer choices into decimals and see which decimal, when I turn these into decimals, which decimals match these decimals, my answers. Okay, so I got to go to the regular calculator mode. Remember, this is really 6 plus the square root of 96 divided by -2, and 6 minus the square root of 96 divided by 2. So I'm going to do plus first, control divide, 6 plus the square root of 96 divided by -2. Is this decimal the same as one of my answer ones? No, so this automatically can't be my answer. Now I'm going to plug this in. 1 plus 2 times the square root of 6. Is this one of my decimal answers?
No.
Nope. I'm going to do C. 1 plus the square root of 96. Does that work? 10 point? No, not one of my decimals. Okay. D. Control divide. 3 plus 2 times the square root of 6 divided by 3. Is that one of my decimals that I'm looking for? Yes. Now I'm going to do it with the minus sign. Control divide. 3 minus 2 times the square root of 6 divided by 3. Is that my other decimal? Yes. So my answer is D. Okay, number 12. Which function's graph has a vertex? What's vertex mean? Highest or lowest point. Okay, the highest point or the lowest point. At 3, -5, and contains point 13, 5. Okay, so how would I do this? What do you think? Graph it. Okay, graph each answer choice. Anytime we're talking about a graph in your problem, you need to graph it, okay? There's no reason we get problems wrong when our calculator can graph for us. So, number 2. All right, I'm going to graph answer choice A. Control divide 1/10 times x plus 3 squared minus 5. Okay, so let's go. Where can I see points at very quickly? Where can I see points at? Control T. Go to Control T. At +3, is it -5? No. What about +13? +13, is it 5? No. So is A my answer? No. So Control T. I'm just going to keep this same graph, tab up, and I'm going to change the sign. The only thing different is now this is going to be a -3. So I'm going to change that to -3. Okay, the fastest way to see if points are on a graph, Control T. I'm going to go to 3. When x is 3, y is -5, so that works. And then we go check for 13. When x is 13, y is 5. So B works. Does that make sense? Okay. All right, 13. Create a function in the form y equals ax squared plus c, where a and c are both values less than 0. Okay? Sketch the graph of the function you created. So if I want a and c to both be values less than 0, what's a number smaller than smaller than 0? Huh? What's this number smaller than 0?
0.25 or less one. No, less than 0.
Negative.
0.25.
Let's just do a regular.
-1.
-1x. Okay. What about a c x squared? What about c less than 0? -4.
Oh.
Okay. What should I do? Graph it in the calculator. Okay, here we go. 2. Negative x squared minus 4. What happened? Shifted down how many? 4, and it's upside down because it's a negative x squared. Okay, 14. 2 points on a graph. Okay, make sure you're watching this one. 2 points on the graph of a quadratic function are shown on the grid. What is the equation for the axis of symmetry on the graph of this function? Okay, axis of symmetry means what? The middle. Okay, so what's the middle between these 2 points? 1, 2, 3, 4, 5, 6. Okay, so the middle would be 1, 2, 3, 1, 2, 3. So this dot is in between them. My axis of symmetry cuts the dots in half. And it crosses what x? X equals -3. Okay, remember axis of symmetry, x is, because it has to be x equals answer. Okay, 15. How does the graph of g of x equals 5x squared compare to the graph of the quadratic parent function? What's the parent function? Y equals x squared. So I want to know, how would 5x squared compare to x squared? So let's go graph the parent function first. X squared. There's the parent function, the original. Now I want to know, what does 5x squared look like? What happens? It's stretched. Good. Stretched. Good. I'm glad you didn't say skinnier. Remember, skinnier is not that math word. Our math word is stretched, compressed, translates, reflects. Okay? 16 is our only problem that's not about quadratics. Okay? Not about from unit 8. So it says, if f of x equals 3x minus 6, find f of 9. Remember, f of 9 means 9 is in the x spot inside the parentheses. So where do I put it over here? In the x spot with his helmet on. Then I just go plug that in the calculator and see what my answer is. 3 times 9 minus 6 is 21. Okay, we get way too confused on that problem. Okay, number 17. Write the vertex of the function below. What's vertex mean? Highest up here or lowest down here. So which one is this? High or low? Low. Right here. And what is this vertex? Remember, it's an ordered pair, x, y. My x is -2. My y is -7. This is my vertex. If I wanted to know the axis of symmetry on this problem, what would it be? X equals the x and vertex, -2. X equals -2 would be my axis of symmetry. 18. Find the zeros. What does zeros mean? X intercept. So how would I know the zeros? Graph. So let's graph it. Okay. Go graph. What have we done almost on every problem?
Graph.
Graph. Okay, negative x squared minus 2x plus 15. And I want to know my x-intercept. So I'm going to turn my trace on. Menu 5, 1. My first 0 or x-intercept is 3, 0. And the next 0 or x-intercept is negative 5, 0. How else did I say you could see this? X equals 3, x equals negative 5. Okay, there's 2 ways you could see these answer choices. As ordered pairs or as x equals. Okay. Number 19. Now, okay, I want you really to pay attention to this because we really haven't talked about this. You know how to do it, but we haven't talked about it together. So take your headphones out and I want you to listen to this. Okay? An object is launched into the air. What is it? Is it Newton's law of gravity? You know what I'm talking about?
Yeah.
Okay, what is it?
Which one?
I guess that's which one it is.
What goes up
Gravity?
must comes down. Okay? What goes up must come down. Okay, so if something is going, somebody throws a ball up, what has to happen to that ball?
Comes down.
It's got to come down. So what kind of graph would that be? A quadratic graph.
Oh.
Okay, it's got to go up, and then it's got to come back down. Okay? So, it says an object is launched into the air. The table below shows the object's height above the ground at various times. Based on the data in the table, which of the following is closest to the object's height above the ground at 10 seconds after being launched? Okay. So, are seconds going to go up and then back down? No. Seconds, the time always goes. Okay? It doesn't ever go backwards. Time is always going forward. Okay? But the height, okay, the height is what goes up and then it's got to come back down. Okay? So, after 1 second, it's at 78 meters. It keeps going up, and then what happens? After 5 seconds, it goes back down. Okay? And I want to know after 10 seconds. And seconds represents which one? X. Okay, so how can I have to come up with an equation to plug in my new X into. Okay, see how it says hint listen spreadsheets because I have a table? Okay, have we done listen spreadsheets with the quadratic? No, but I'm going to show you. It's the same thing. So let's go do listen spreadsheets. Okay, so X and Y. 1, 2, 3, 4, 5, 6. Everybody should be doing this with me because it's new. 78, 109, 131, 143, 145, 137. I'm going to give you a second to get all that plugged in. Okay, what kind of problem do we say this is? Is this going to be a linear problem? Is it going to be a straight line? Is it going to be exponential where it starts low and then it goes up super fast? No, the ball does not travel like that in the air. Okay, it's going to be something that goes up and then comes back down, right? The ball's not going to keep going up forever. Okay, so what type of graph is this going to be? We said this was going to be a quadratic graph. Okay, so when I do menu 4-1, I don't want linear, I don't want exponential, I want quadratic. Number 6, X and Y, everything stays the same, enter, enter. Okay, remember, our standard form is ax squared plus bx plus c, right? So my a, I'm going to round negative 4.9 x squared. My b is a positive 46.2x. And my c is going to be positive 36.5. Okay, I want to know after 10 seconds, what am I going to do with that 10? I'm going to plug it into the X spots, both X spots, and what's got to be around that 10? Parentheses. So I'm going to plug it in my calculator. Negative 4.9 times 10 squared.
You got the point.
Oh, you're right. It did a 0 instead of a point. Point. There we go. Click 0. Okay. Negative 4.9 times 10 squared plus 46.2 times 10 again, because there's another x, plus 36.5. And after 10 seconds, the height of the ball would be 8.5 meters. 8.5 meters. Questions? Okay, we all know how to do list and spreadsheets, right? Okay, but this time you're going to quadratic because we're talking about quadratics. All right, number 20. What is the graph below have a, or does the graph below have a maximum or a minimum, and what is the value? Okay, is my vertex at the highest or the lowest? Highest, so that's a max. And then it wants to know, what is the value of the maximum? How high or how low is this? It's high, but how high?
2.9.
Okay, I only want 1 point. 2, okay, you guys are saying 2.9. 2, okay, if I'm talking about height, when you go to the doctor and they're measuring your height, do we ever go sideways? No, what do you do? If I want to know how high, okay, how tall or how short you are, we're going to go straight up to the highest point on your head. Okay? We don't measure the last part that touches the wall, right? We touch the top of your head, and that's at positive 9. Okay, any questions? Okay, good luck on your test.